Yeah, we'll be looking at the differentiation of inverse function. Differentiations of inverse function. Yeah, we'll be looking at differentiation of inverse function. And these are the inverse function. Y equal to arc sine x, y equal to arc cos x, y equal to arc tan x. This is what I mean. Y equal to arc sine x. Okay, so that's another way to do that. Okay, so what we do is this. It's very simple. I want to see how we can differentiate this inverse function. The inverse of sine, how can we differentiate it? The inverse of cosine, how? The inverse of tangent, how can we get the differential coefficient? Okay, let's start with the first one. Y equal to arc sine x. That's the inverse of sine. The first thing you do, you take sine of both sides. Take sin of both sides. Take sine of both sides. Of both sides. Take sine of both sides. So that will give you sine y equal to what? When you take sine of inverse function, it's going to give you here, it will give you x. Okay? So that will be equal to, I can change my hand and write like this. Then x is now a function of y. So differentiate respect to y. So the x, the y. And the derivative of this one respect to y is cos y. So the next thing to do now is to play with the identity cos square x plus sine square x. Cos square x plus sine square x equal to 1. Can we make, if we make cos the subject, so cos x now will be equal to square root of 1 minus what? Sine square x. Okay, so this will be equal to the x, the y will be equal to 1 square root 1 minus what? 1 minus sine square y. Our function is y in this case. Okay, then we can replace that. Our y is what? Our y is what? Okay, sine x is what? Is x. So that will be equal to 1 minus sine is x. So x squared. Okay. Then can you take the inverse of both sides? If you take the inverse of this, you have the y, the x. Take the inverse of this, you have 1 over 1 minus x squared. So this is the derivative of this. If you are looking for derivative of arc sine x, okay, this is the answer to that. Okay, let's go to number 2. Y equal to inverse of this, of cosine. I think I can say here, take sine of both sides. Take sin of both sides. Okay, so here also, all you do is just also, we want to remove this inverse. So by so doing, we take the cosine of both sides. Take cosine of both sides. So that will be cos y equal to what? And when you take cos of this function, will give you here. So that's that. Give you the x. Can you change your x equal to what? That differentiate respect to y. Differentiate. You don't have to differentiate respect to y. So we have the x, the y. Okay. Equal to. This one will give you minus sine y. Okay. And this will be equal to minus square root. Don't forget one here. Take your sine, the subject, and that will be what? 1 minus cos square y. Can you make substitutions? Cos is what? Cos is equal to what? X. So we have p dx of y is equal to what? Minus square root 1 minus what? 1 minus x squared. Then take the inverse of both sides. So the y dx is equal to what? Minus 1 over square root of what? 1 minus x squared. So that's that for the differential coefficient of arc cos x. Okay, that's the differential coefficient of the inverse of what? Inverse of cosine. Okay, inverse of cosine and sine, they are the same. It's just that this is positive, this is negative of that. They are the same. This is positive, this is negative. So let's let's go to the third one. Let's get the differential coefficient of inverse of tangent. Okay, arc tan x. Arc tan x. This is a pronunciation arc tan x. Okay. Yeah. So step 1, take tangent of both sides. So that will be what? Tan y equal to what? Equal to if you take tan of this function, so that will be equal to what? X. So I'm having now x equal to what? Tan what? Tan y. Can you differentiate respect to y? So we have the x, the y. If you differentiate tangent, you have sec square y. Okay? And don't forget that sec square y is equal to what? 1 plus what? 1 plus tan square y. So the x, the y, we got to, I'm going to make substitutions here. That's 1 plus. Tan y is x from here. So that'll be x squared. Okay? So can you take inverse of both sides? So the y dx is equal to what? 1 over 1 plus x squared. So that's the differential coefficient of the inverse of tangent arc tan x. The differential coefficient is 1 over 1 plus x squared. So let's see applications of all these. Okay, let's see applications of this. There are others, there are more, but we just, for this case, we just stop here and then go to question. There are still arc cosine y equal to this one. Okay. There are still other ones, but they just stop there. Question. So this is find the u, the theta if 1, u is this. That's the first question. 2, u is this. So let's see the solution to that. So u is equal to what? Arc sine 3 theta. Okay. Can we make it u equal to arc sine v, where my v is what? 3 theta. So what we are saying here is that u is a function of v and v is a function of theta. So this is a function of functions. Okay. Then the u dv is equal to what? 1 over what? Square root of what? 1 minus s squared. Okay. And then the v, the theta is 3. Okay. So can we get the u, the theta on the question? The u, the theta. Okay. So the u, the theta is equal to the u, v times the v, the theta. Okay. And my the v is this 1 over square root of what? 1 minus s squared times 3. Okay. So my du d theta is 3 over 1 minus s squared. So that's just that. Okay. In a nutshell, it's very simple. If you don't want to do all these long steps, what we just need to do is for you to get the inverse of this. Get the differentiation of arc sine. Okay, which you got what? 1 over square root of what? 1 minus there's a little alteration here. Our u here is a function of v, so it's going to be 1 over v squared. Okay. So, and that will be equal to here also 1 over b squared. Okay. So finally, we need to substitute back. We need to substitute v. Our v is what? Our v is 3 theta. So that will be, if you square that, that will be 9 theta squared. So that is the answer for that. So that's that. So as I was saying, if you want to do it directly, straight away, it's very simple. Just get the derivative of this one, sine, which will be arc sine this, which will be equal to what? 1 over, what do you have here? This is what? Theta. That's your x now. That will be theta, 3 theta squared. And then times derivative of this times 3. That will say time. Okay? I'm going to do the second one straight away. U equal to arc tan 3 theta cube. Okay? So your du, the theta, is very simple. First of all, get the derivative of this inverse of tangent, which is what? 1 over 1 plus s squared. Your s squared in this case is what? 3 theta power 3 all squared. Okay? And then times the derivative of this inner function. So which will be equal to what? D dx. Oh no, d d theta over 3 theta power 3. Okay, and that will be equal to 1 over 1 plus. This will be 9 theta 6. 3 squared and 3 cube power 2. And then times this one, which will be equal to 3 times 3, that's 9 theta 2. Okay, so your answer is what? 9 theta squared over what? 1 plus 9 theta squared. Okay, is 6. You can see the 3 theta cube power 2. So we got to 3 squared theta cube power 2. So that will be 9, and then this will be 3 times 2, theta 6. Okay, so that's the answer to that questions. It's very straightforward. Very straightforward. Just get the derivative of where is it? Of this arctan, which is what? 1 over 1 plus whatever you have here. That's a function. Then you square it. Okay, and then times the derivative of this inner function. And that's all. That's all. That's all. Next question. This will be equal to the differential coefficient of this function. That's 1 over square root 1 minus. What do you have here? That's a function. 1 minus x squared over 1 plus x squared. Okay? Or square. That's the first thing you have to do there. Okay, don't forget that if you have d dx of arc sin x, this will give you 1 over square root 1 minus whatever you have here, x squared. So my x in this case is the rule of expression here. Okay, so times the derivative d dx of that internal function, 1 plus x squared times that. Okay, so can we get this derivative of this one? d dx of 1 minus x squared over 1 plus x squared, which will be equal to 1 plus s squared all squared. Then your numerator, your v is 1 plus s squared. Okay, the derivative of the numerator is minus 2x. Then minus numerator 1 minus s squared times the derivative of the denominator. That's 2x. Let's do the expansion. That will be this one times this one minus 2x. This one times this one minus 2x cubed. And then this one times this one, that's 2x times minus 2x. Minus times minus, that's plus. And this one times this one, 2x cubed. So this one will cancel all over 1 plus x squared power cube. So for that now, for d dx now of 1 minus x squared over 1 plus x squared, I'm having minus 4x over 1 plus s squared or 2. So that's that. Then the next thing to do, can we work out this one? That's a radical. This this one minus 1 minus x squared over 1 plus s squared or square. Let's work this one out. Okay. So this will equal to this power, this one times this one, that's 1 plus s squared power 2 minus 1 minus s squared power 2 all over 1 plus s squared. Okay? Square root. We can do the expansion. 1 plus x squared power 2, that will be 1 plus 2x squared plus x4. Then for this one, that will be minus 1. This one times this one, that's minus. This one times this one, that's s squared times 2. That's minus 2x squared. Then plus this one last one here, x4 all over 1 plus what? 1 plus s squared. So then you can open. If you open, this one and this one will cancel. Then you have 1 also will cancel. Then you have minus times minus, that's plus. You have 4x squared over 1 plus x squared. Okay? Or square root, which will be equal to what? 2x over square root of what? 1 plus x squared. Yeah. We've done this expression here, this expression of the radical here, which is this one. But don't forget there's 1 on top of that. So that will be, take the inverse of this, which will be equal to what? Root 1 plus s squared all over 2x. Okay, you take the inverse of that. Okay, and then times the derivative here, which we have here, minus 4x over 1 plus s squared power 2. So this one will cancel, this one will cancel. Then this one and this one, that's minus 2. Then you can combine this one together. That will be all over 1 plus s squared. We have the same base. This power half, so half minus 2. Half minus 2. So that will be equal to minus 2 over 1 plus s squared. Then half minus 2, that's minus 3 over 2. So that's that on that question.